Okay, it is the top of the hour.
Yep.
And so I would be happy to get started if everybody's ready.
Yep.
Okay. Good morning, good afternoon, good evening, wherever time you are, wherever you're joining us from. Thank you for joining us. My name is Kurt Parker. I'm the product marketing manager at Microchip. I am in our 32-bit microcontroller division. And it's my pleasure to welcome you today to the introduction to PingPong IoT's Quickstart Board webinar. In today's webinar, Ben Hoke will tell us more about the PingPong. Now, let me give you a brief overview of the topics we're going to discuss right now. At first, Ben will tell us about which markets will transform the most with the Internet of Things. Then he'll discuss how you can develop your IoT applications using PingPong. And lastly, how you can benefit from the modular hardware concept. So hello, Ben. I hope you're doing well today.
Yes. Hi, Kurt. How are you doing?
I'm doing fantastic. Thank you very much. And it's a beautiful day here in Chandler, Arizona, where we're based out of. So couldn't be better. So why don't I go ahead and pass the presentation on to you, and you can fill us in on what you're presenting today.
Oh, thank you very much for the introduction, Kurt. Also from me, a warm welcome to everyone. So as Kurt said, my name is Ben Holke. I'm the founder of Ground Solutions, based at the business of Frankfurt, in the middle of Germany, middle of Europe. As a hands-on CEO, I'm also pleased to be leading this webinar today. Introductions can always be a little bit tricky, what's most relevant to say and what parts to leave out. But just a personal note, I could say I'm married, have 2 children. I've been in this field for nearly 20 years, but my passion and focus is very much about the current technology, about the future, and especially in the area of wireless. So all in all, I think it's fair to assume that we have a lot in common here. The objective from my side today is to offer you the opportunity to create and develop your applications in a much faster way than before. So I will jump in. So it's very much about the desire to invent from simple ideas, change the world, or at least improve the lives and becoming more effective. I think there's been a lot of innovation in the tech field, but in the world of things, I think that hasn't been the case. So I want to go as far as to say that I think it's vital for our societies even to keep inventing in the world of things. And there's a lot of possibilities, and this is the reason why I'm very excited about the IoT. So we'll now have a look into some areas where we think we can help specifically. And one area here is the automotive area. So this is how things look today. It's a mess. It kind of sucks. And there is still a lot of possibilities of new applications in this area. If we move into the elderly population, so we have a growing challenge on our healthcare systems. So the key word here is remote monitoring. And also here, there's still a lot of opportunities in this area. Particularly where the country where I'm now living, Germany, is famous for its manufacturing capability. However, also here, there is a growing need to increase efficiencies. And the buzzwords on the slide here, more into predictive maintenance, reducing downtimes, and so on. And I also think there is a global competition going on between Asia, US, and Europe, and it's a matter of increasing efficiencies in order to stay on top in the in the future to come. The other day, when I drove back home from the office, I saw this, and we have a huge issue or challenge in the environment. And also here, I think IoT has an enormous potential to connect to the old, let's say, things and help us improve our environment. So these are a couple of examples of where we have looked into applications for the PingPong platform. So in summary, we think we have some good news for you to help you solve problems. So we now shall have a look at some of the solutions. Some of us looked into solutions based on fruit. We can quickly conclude that for professional use, raspberries and the like are not really suitable. For prototyping, of course, it's a low-cost way. It's also quite fast, but it's not so much more than that. So I'm very delighted to be able to present to you the ultimate solution. This device has been developed based on the Microchip PIC32 processor. And what's genius about it is that it's modular. So you have a baseboard. We have these two white, let's say, connectors. And then on top of this baseboard, you actually adapt an unlimited number of extension boards. And we will go into all this now in the next charts and minutes. So if we look at the baseboard, so what we have is the PIC32 MZ. So this is the microchip controller. There is a cellular engine. There is a GPS, there is an accelerometer, magnetometer, there is an Ethernet connector, there are different IOs, which we go into detail later, there is a USB. So if we start from the bottom here, on the lower end, so this is where the things would be connected through different types of interfaces. So it could be the analog, the 420 milliampere input. It could be the IOs and so on. So we have the things at the bottom, and then information is all processed by the PIC32 MZ. It has 2 megabyte flash. It has 512 kilobyte RAM, and that all information is then going through the cellular network or Ethernet network over the internet into a cloud-based database. So let's say to explain a little bit more about the concept. So we have USB here to connect to the host device, but also the USB can be used for debugging and uploading, downloading the programs into to the PIC. We have 2 SIMs and also a design for an eSIM. We have a very wide range of power supply. We have the accelerometer, magnetometer. So accelerometer is for detecting movements. Magnetometer is then the level, horizontal, vertical, etc., where you can, if it's upside or downside, and so on. We have the 2 extension connectors. We have a positioning component. And what I like to say now is that some of you might say, hey, I don't need all this, or I don't need some parts of it. I don't need a GPS or positioning a component, because that's add any value to my application. And the way we designed this is that we can strip off components. So we could strip off the GPS receiver. We can strip off several of these components. The Ethernet connector, for example, is quite expensive. So we can strip off, and we can do the other way around as well, that you say, well, for my application, this is what I need. And then we would pull all the absolute minimum components just together, and hence we will reduce the BOM significantly. So let's look at some of them a little bit more in detail. Here we have the internet connection. We have Ethernet and cellular to be able to connect to the internet. So the cellular side, we have chosen a module from Telit. It's a module which is pin-to-pin compatible for 2G, 3G, 4G. And now with the 4G, we have narrowband IoT coming out. We have the Cat M1 coming out. And so we have a really totally flexible solution on the cellular side. You also receive a terminal program from us. So because the cellular module, you drive with AT commands. So we provide you with that terminal program. In terms of the positioning, we have picked a positioning module, a GNSS module, which can do both GPS and GLONASS. And in this case, it's also from Telit. By the way, Telit is also a partner for us since virtually day one, so more than or around 17 years now. So for the cellular and for the GPS, we're using the Telit module, and this Telit positioning module comes in two versions. So we have a standard version, which already has very high accuracy because of the two systems, GPS and GLONASS, but there is also the automotive grade, which supports dead reckoning. So here we're talking about positioning accuracy of centimeters. And lastly, is that we also provide a service which uses the cellular network to improve accuracy even further. So let's move on to IOs. So we have 4 digital 3-state inputs. We have 4 digital outputs. We have frequency counters for, RPM to read this out. And if some of you would say, well, actually, I need more than that, then we can add an extension board on top of the baseboard to ensure that there are IOs. For the 4 to 20 milliampere current measurement loop, so we have 2 inputs, 2 analog inputs for this, and the specific thing here is that we have a high-resolution ADC chip from Microchip for the measurement loop, and followed by a digital isolator, as this is a requirement for most industrial sensors. Okay. So buses and protocols, we have Ethernet, CAN bus, one wire, and Modbus, for example, is really very important in industrial machines, PLCs, and so on. This also exists. And we will talk about that on the firmware side a little later on as well. I mentioned before the 2 expansion connectors. So these are the 2, and this is, the communication buses hold this number of protocols for communicating with the next up board, and we'll also have a look at some of the extension boards quite soon. So this is the summary of the board. Of the concept of the baseboard extensions. And the first one I would like to show here is the RS485 Modbus board. So it has its own PIC controller, so it's a PIC32 also on this one. And through the USB interface, it actually can also work as a standalone. And source code is available also here on this. And I will, as just said, will explain to you how the source code and the SDK, how that works in a few minutes. We have a Wi-Fi Bluetooth expansion card. Here is a PIC18 on board. There is a Microchip Wi-Fi Bluetooth module on this one, and also this one has the capability of being a standalone as well as pluggable to the PingPong baseboard. And the last one in the expansion cards I like is the ISM card. So here we're working with three frequencies. We have 433, 868 megahertz, and for the US 950 megahertz. PIC18, and also it can be configured or can be manufactured with a USB connector to standalone. Okay, so now we're done with the hardware part. So let's have a look at the software and the firmware. And we tried really our best to make it very, very easy for developers to write application on the PingPong board. So let's have a look how that works. So we have done a firmware development kit for you. So all hardware communication code is encapsulated in libraries, and using them is really simple. So as a developer, you don't have to worry about the USB implementation, TCP connections over Ethernet or over the cellular side, the 2G, 3G, 4G. So the figure shows how some of these libraries you get with the development kit. Of course, there are much more, and there are also libraries for the expansion boards. For example, memory read and write, I/O handling, and so on. So we provide you with a sample code and how to use it with State Machine or with RTOS. So all devices come with a preloaded, with a bootloader on board. Some applications require developing just tens of lines of code only when using these libraries. So it can be really done very efficiently. And since we're using 32 microcontroller, the development environment for the users is MPLAB's IDE. So you need the XC32 compiler and an MPLAB Harmony. The basic firmware is provided that allows, for future firmware upgrade, and we've done this over USB, Ethernet, and over the cellular modules to 2G, 3G, 4G. So if you have questions on this here, please note them down, because towards the end we will have our Chief Design Engineer joining us for taking questions. So here are some firmware which we have written for the PingPong platform. So the RS485 with Modbus, the location tracking, the TCP tunneling, and with the current analog measurements. So as a little bit as a summary to say here, we have two types of customers. So one set have a little bit smaller number of devices. So this could be, let's say, in the hundreds, which will take a PingPong, and it might be that they tell us, hey, let's strip off some of the components to keep the cost. So in the beginning, I mentioned perhaps not everyone wants the GPS, so we will not have the GPS on the board for such a requirement. And then we have another set of customers where they come to us and say, hey, we really like the design. Can you help us design that into our board? Or we like the design much. We have tested the PingPong, but could you do some modifications to it? So it's even more specific to the requirements I have. And since we have the R&D team, development team here in Frankfurt, and we also have in-house manufacturing capabilities here for prototypes, so we can turn around designs and redesigns extremely fast. So we've talking about that things provide all the data. We ship them, we send them over cellular into the cloud. But what's happening actually with all this information? Where is it stored, and so on? And we have developed firmware which allows the PingPong to send the data directly. In this case here is to a Telit cloud. But of course, this can be adapted to any other cloud. And we've been using HTTP requests for doing that. So we have like a cloud system ready to showcase for anyone who is wanting to check it out. And this would be an example how the portal looks like. This is the main, let's say, it's not the dashboard, but it's the upper front end for the connections. So if you see here, Telit IT portal, there are the different tabs for the different, let's say, dashboard for seeing the information, where the things are, and so on. So we are getting towards the end, but there is one more important thing, actually, and that is security. And we have 2 points to make here. So because we work as a design partner with Microchip, and we're using the Microchip encryption technology, specifically here when we're going through or using the internet. And from the cellular side, we're using most of the time the TLS version 1.2. So I think that explains about the security side. So I'd like to wrap up a little bit. A couple of words about Round Solutions before we open up the Q&A. We've been working with this technology, M2M IoT. Previously, it was called M2M, machine-to-machine communication, for nearly 20 years. We support customers in these four areas. So ready-to-use IoT, hardware, firmware. This would be the example, the PingPong. And we do the design and prototyping. We have a whole set of components, particularly through our partnership with Telit. So this is cellular, this is a GNSS, so the positioning, Wi-Fi, Bluetooth. There's a lot of antennas, embedded and external antennas also under this business unit. And then lastly, the IoT platform connectivity. This also, we work in partnership with Telit to provide customer like showcases and help them to get proof of concept done in a very fast. One small remark about the PingPong platform, and it's available on the Microchip Direct portal. There's a promotion price of $299 for it, and you might say, well, okay, sounds a little bit much, but it's a 3G cellular module on board. There's the free firmware for a whole bunch of different types of applications, extended technical documentation, and you have direct access to our R&D team here in Frankfurt. So overall, we think it's really good value for money. So I'd like to close then by thanking everybody and saying over to you guys. Okay, I see a question here. Is the product already available? Yes, it is. And it's already deployed in the field at a number of customers. Which are the key customers you like to address? The key customer, one set of customer would be software developers who don't want to reinvent the wheel by asking their colleagues to do another hardware platform. So it's a multifunctional hardware platform for software developers. And in terms of verticals, I think I mentioned a couple of verticals in the beginning where we already have done some firmware with, and where we already have some deployments and some customers using it. So this is an industrial machinery, for example, with the RS485 with the Modbus. It's within the tracking area. So these would be some examples. And usually we work with industrial company, with system integrators, with the developers. We have Microchip as a reseller company, but most of the time we work directly with the let's say end customer, which is a system integrator. Okay, we have one question here. From which quantity can we get our own design? This we will do on a case-by-case basis. So if you contact us, and we have a dialogue of you know, what you want to change, so then we will do a technical description of what needs to be changed, and then assess the complexity and the time needed to implement such a change, and have that let's say faded into our usual roadmap and schedule of design projects. Okay, so where does the TCP/IP stack execute? On the Telit module or on the PIC32? I will hand over here to the Chief Design Engineer, who will explain it a little bit to you.
Yeah, hello, this is Mason. When it comes to connectivity over the cellular module, so we use the TCP/IP stack that is on the Telit. So we simply execute 80 commands to set up a socket connection, and then we can either do a direct connection, like send raw data, or we can build the HTTP posts and send them over to do the HTTP requests. But of course, when we want to do the Ethernet connection, we run the TCP/IP stack on the PIC32.
Can you support messaging protocols such as MQTT? Yes, we can. Mason, do you want to say something more about it?
No, I just say that this we can. We have already run an application. The connection to the Telit cloud in one application is over MQTT, so this is supported. We can confirm that.
Yeah, I think it looks like these were the questions. We will post some Q&As after this webinar. So if there's no more questions, thank you very much for joining in. Thank you for listening, and we hope to hear from you back. Thanks again.